All right, so dot product, we're just going to multiply first times first and add it to second times second. So this would be 14 plus a negative 24, and you should get negative 10. Number 2 says find the angle between U and V. So cosine of theta equals the dot product over the magnitude of U times the magnitude of V. I already know that, so in the calculator, I'm going to write cosine negative 1. And then the dot product is negative 10. I already got that part. The magnitude of U is the square root of a squared plus b squared. 49 plus 9, so square root 58. And then the magnitude of V is the square root of 2 squared plus 8 squared, 4 plus 64, which is 68. And then when you type that in the calculator, you can actually like use one square root bar and just go 58 times 68, that's fine. But if you're not going to use the fraction, which is what I recommend, use the fraction to set up negative 10 over that. Make sure you group it together, so 58 times 68. 99.16 degrees. So if you drew it, it should be obtuse. So like if I drew those two, it should be obtuse. And then the number 3 says to determine if they're orthogonal. So how do I know they're orthogonal? I could put B over A, and so here it would be negative 3/7, and here it would be 8/2, which would be 4 over 1. And then compare them. If they're the same, it's parallel. If they're the opposite reciprocals, it's perpendicular, which means orthogonal, or neither is the option. These are not, or no, they are not orthogonal. You can also look at what? What else tells you? The dot product. If the dot product is 0, then they are. So you can kind of save yourself some trouble. Probably on your test, you'll get given the parallel, orthogonal, or neither. So you'll want to set up your slope either way. But this time you didn't need it. All right, chapter 6, section 5 is called trig form of a complex number. So it is like not really vectors, okay? Some of the stuff we talked about in the last section is going to carry over, but for the most part, this is completely different, okay? This is also the last section in chapter 6. Like I said before, we're going to start chapter 7. Chapter 7 starts with systems of equations. So we're going to start with substitution, elimination, that kind of stuff. And then that's where your next test will cut off. So complex plane is how we graph a trig function, okay? So these are going to be 2 different formats, trig form and then a complex number. And on a complex number, we graph it on a complex plane. It looks exactly like an xy axis. The x-axis, except instead of it being the x-axis, is called the real axis. And the vertical axis, instead of it being called the y-axis, is called the imaginary axis. If you look at the x, they are all regular numbers. But if you look at the y's, these have eyes on them, okay? So imaginary being the eyes. These kinds of coordinate points will be in the format of something like 2 plus 7i. The x is the first part, right? The part without the I would be on the x-axis because that's the real part. And then I shouldn't have done 7. I should have done something like 2, okay? Let's make that 2, so it's actually on this. I would go to the right 2 for the real part, and I would go up 2 for the real part. For the imaginary part, and I would plot it. It's a point. That's all it is. This is not a vector, okay? We're going to learn, obviously, how to plot these, and then we're going to learn how to convert them from complex into trig and trig into complex. That's what today's section is about. The absolute value we are going to find of the complex number is found by the square root of a squared plus b squared, which should look familiar, right? Because we use that same formula for what? The magnitude. So absolute value is basically just like finding the distance between the point and the origin. So if I had plotted, let's say it's 3 plus 2i, I would go to the right 1, 2, 3. Well, that's 4. I would go to the right 3, 1, 2, 3, and up 2. That's my complex point, okay, which is just a point. But if I wanted to find the absolute value of that, then it's the same as enclosing this into a right triangle and finding the radius. It's the exact same process. You just don't have to draw it out. You do the square root of a squared plus b squared. Example 1 says plot and find the absolute value. So for A, negative 3 plus 6i, I go to the left 3 and I go up 1, 2, 3, 4, 5, 6 would be up here. God bless you. And then the absolute value would be the square root of negative 3 squared plus 6 squared. 9 plus 36, which is square root 45. And then you want to make sure you simplify it. That breaks down. This is 5 and 9 is 3 and 3. So this is the same thing as 3 root 5. With me so far? Easy stuff, right? All right, 2 minus 4i to the right 2. No, it really is not bad this time. To the right 2 down 4. Obviously, it doesn't stay this easy the whole time, but that would be 2 minus 4i. And then square root of 2 squared plus negative 4 squared. 4 plus 16, square root 20, which is 2 root 5. You will have a question on your test that says plot it and then find the absolute value. You just have to know what absolute value is and you're good to go. Because that's not a normal thing. Like the absolute value, you normally put it in absolute value bars, make it positive, but that's not what you do with these. Good? Questions? All right, so this is converting from complex into trig form. So, all right, the complex form was your a plus bi. So something in complex form could be 2 plus 3i. It could also just be 5i by itself. Like that would be 0 plus 5i. Okay, those are complex form. We're going to take that and put it into something called trig form. And in trig form, your answer will look something like this, where there's a number at that front and the number is the radius, times the cosine of theta, and we're going to replace theta with an actual angle, plus I times the sine of that same angle. You can also distribute your r in, so it would be r cosine theta plus I r sine theta, or I r or r I, like this can be switched, it doesn't matter, okay? But in that way, that kind of overlaps with what we did with like when we're trying to find direction and magnitude, right? If we had the direction, which is the angle, and we had the magnitude, if you wanted to know the coordinate points, you did the radius times the cosine of theta and the radius times the sine of theta. So for that, it's almost the same. The only difference is the format. So the first term, you'll leave the actual angle in it. The second term, you also leave the angle in it, but you give it the I because the I would be what makes the complex form. To find r, we do it the same way we've been doing it. R would be the square root of a squared plus b squared. And then to find theta, we do what we did at the end of like the notes from 2 days ago. We would say tan of theta equals, that was our change in y over our change in x, right? Our change in y now is the b, and the change in the x is the a. And then these will be unit circle based tangents. So there's only so many options you can get. I'm going to review our unit circle based tangents real fast. So on the unit circle, tangent is 0, right and left. It's undefined top and bottom. And then all the over 6s, all the over 4s, and all the over 3s have the same value. The sign changes, but they all have the same tan value. Do you remember what over 6s is? Root 3 over 3. Who said it? Good job. Root 3 over 3. What are all the over 4s? 1. And what are all the over 3s? Root 3. So then if you know that, and you know the signs as you move around, right? Tan would be positive in the first quadrant, and it's positive in the third quadrant, because all students take calculus. And then it would be negative in the second quadrant, and it would be negative in the fourth quadrant. And then if you also remember the angles in these quadrants, the trick to knowing the theta in here is that the numerator was 1 less than the denominator. So this is your 2 pi over 3, 3 pi over 4, and 5 pi over 6. In the third quadrant, it's 1 more. So this is your 7 pi over 6, 5 pi over 4, and 4 pi over 3. And then in the fourth quadrant, it's 1 less than double. So 5 pi over 3. What am I saying? 7 pi over 4, thank you. And 11 pi over 6, okay? So if you remember that, you do not need to do your whole unit circle. Like, there are going to be tricks that eliminate that work for you. So hopefully things like that help. Now here's the tricky part if you don't pay attention to it. Once you understand this, it's not bad, but the tricky part is that you are going to get from your tan of theta equals b over a, you're going to get something that says like tan of theta equals, for example, let's say root 3. Now, from that, if I just ask you, where on your unit circle is tangent root 3, what are your answers? Give me the radians. So what two angles have a tangent of root 3? Pi over 3 and 4 pi over 3. Now, only one of these is right, and you will know which one based on the original location of your coordinate point. So if this coordinate point at the beginning was, let's say it was 1 plus root 3, because that's what it would be, okay? Let's say it's that. Where would that be located? First quadrant. So that answer would be the pi over 3, okay? If that was my original question, I would pick that one. But if my original question said -1 minus root 3i, where would that be? Third quadrant, and for that one, I would pick the 4 pi over 3. So the very first thing you want to do is figure out what quadrant your point is in. And then from there, you'll know which one to pick, okay? Because it is not that there are two that are right. Only one of them is right. So that my whole explanation there is what that bottom bullet point says. Use the value of tan to find the reference angle, and then the location of the original point to find the quadrant. All right, let's work it through. So I will be very honest, there's like a super easy way to do this, and it is to plot it and figure it out. But we're going to go through the long process because this type of question is not all going to be that way. So this by itself in complex form would be 0 plus 3i, right? Where would that be? It's actually on the axis, and that's why this is unique. Because already you should be able to tell me the r and the theta. What would be the radius there? Radius is the distance from the center. 3. My r would be 3, yes? And what angle am I at? 90, but put it in radian form? Pi over 2. So already you would get those things, okay? But that only works on a quadrant angle, so we're going to go the long way. We're going to say r equals the square root of 0 squared plus 3 squared, square root of 9, which is 3. There's the r, and that's how I would have to get it if it was anything other than on the quadrant. And then the second part is that the tan of theta equals 3 over 0, which would be undefined. And if it was undefined, what two angles could it be? The top or the bottom, pi over 2 or 3 pi over 2. But because we know where this lives initially, we pick the 3 pi over 2. We pick the pi over 2. Now we got to put it in the format it's supposed to be in. So the r, which is the 3, goes on the front, times cosine theta, which is pi over 2, plus I sine theta, which is pi over 2. Or distribute. You could also distribute and be 3 cosine pi over 2. Yeah? It doesn't care. It'll take both. Okay? What it will, like if you miss the I, obviously it will mark it wrong. And this is your normal I. We're back to the normal I. This is not the IJI. So you're back to your normal I on your keyboard. Okay? And if you wanted to check this answer, you would like literally go, okay, what is pi over 2? Well, the coordinate point at pi over 2 is 0, 1. And the cosine there is 0. And the sine there is 1. And I would end up with 0 plus 3i, which goes back to your question. Okay, so these all can be checked. Questions on that one? All right. Oh, sorry. All right, so start by figuring out where this would be. -2 is going to be where? Third quadrant. Back 2, down 2. So first of all, I know I'm only picking from the angles that are in the third quadrant, okay? So for my r, square root of negative 2 squared plus negative 2 squared. 4 plus 4, which is square root 8, which is 2 root 2. That's my r. Then I'm trying to find the angle that this forms with my x-axis. So what I can do, and this is why it's tangent. What you can do is, I don't need to get this, but this is why we're doing what we're doing. I don't need you to draw it every time, but I can close that in, right? And this is negative 2, and this is negative 2, and this is what I'm trying to find. So that's opposite and adjacent. The tan of that angle is equal to the side opposite it, which is the B, over the side adjacent to it, which is the A. And so I get tan of theta equals 1. So what angle has a 1 for a tangent? And over 4. What quadrant am I in? Third quadrant. What's the over 4 in the third quadrant? 5 pi over 4. 1 more than your denominator. Does that make sense? Okay, good. All right, now I got to put it in trig form. So 2 root 2 times the cosine of 5 pi over 4 plus I times sine of 5 pi over 4. And if it were me and it was web sign, I certainly would leave that 2 root 2 in the front. I wouldn't have to write it twice. But you can also distribute it. Yeah. This answer, then I would 5 pi over 4 is negative root 2 over 2. All right, that would be negative 2 root 2, negative 2 root 2. So if I want to check it, 2 root 2, cosine there would be negative root 2. Plus I, sine there would be root 2. And then I could distribute 2 root 2 times a negative root 2 over 2. These cancel, and root 2 times root 2 is 2, and it's negative. Do it again, and this time this would be positive. Wait, no, this should be negative. This should be negative. So that is not, you don't have to do that. That is to check your answer, okay? You can stop here. Cammy.